review hackathon. I've been to many hackathons myself, but usually in hackathons you have a group of people sitting in the same room. They cook overnight, and you offer them free drinks and free snacks. But last time we had the social movements, so we couldn't make it, and we had to run virtually. And at the time we thought maybe we can make it better next time. But this year we got COVID, and it's even worse, so we had to do it again virtually. And I know it's going to be difficult for you guys because you have to communicate with your teammates remotely and collaborate with them. But I know it's not going to be easy, but I just hope you guys to have fun. That's the most important thing. I hope you enjoy it, and if possible, you can make some new friends and learn some new things. So, before we start, I just want to remind you again to practice social distancing, not only in this room. When you're outside taking the refreshment, taking the food, you have to follow these rules. Today Tong has been tested positive, so we don't want to follow it. So here's what we're going to do tonight. In a few moments, I will pass the stage to Mr. Tong. He's from the Hong Kong Observatory, and he will give you a talk. And hopefully, from his talk, you can get some inspiration on what you are going to work on in the hackathon. And after that, I'll use like 15 minutes to give you some general information about the hackathon. And we will then invite our VIPs, our guests and sponsors, to come up and give you some welcome remarks. And after that, we have food. Light refreshment will be served outside. And I think you shouldn't, I don't think you're allowed to bring the food here to consume. So you have to consume them outside. And if you don't have a team already, we'll give you time to brainstorm and form a team and just network with others. So it's time, I'm about to pass the stage to Mr. Tong, and he will talk about climate change.
I say a few words. I'm Dr. Tan, right? So you know me through Zoom. And I just want to give a quick breakdown of the students here. Today we have really a huge group of students, close to 60 who have signed up. And all of you students are very bright and talented, right? You work with me, right? So over the last few months, under the Hong Kong AGE program or under the Education Reward Project program. So what I want to say is this: thank you for coming, and it is very important that you take away something today. What would you take away, right? Because think about it, this is a prestigious international STEM event. It's going to be held worldwide at the same time. We want to encourage each one of you to sign up for this NASA SpaceApps, and depending on what were the things that you have been doing, is it mathematics, is it programming in Python, and so on, to bring that in, right, as part of your learning that you have been doing in the last few months as well. Okay, so this is something that I want you to take away. In other words, how can you make use of today's events, make use of what you are going to do today as part of your continuation of what you have been doing with us at the Hong Kong AGE program or at the EDP program. And we have very good people here today, judges, who will also share with you later after Mr. Tong's talk. So that's something you want to grab them and ask them questions. How are you going to judge high school students? In fact, this I want to say is very, very, very interesting this year. Unlike last year, this year we have reached out to secondary school students, and we want to encourage all of you to participate officially. Right? You're not here just to listen to the talk, right? But also to participate officially. So later, ask the judge at 5:30 after Mr. Tong's talk to answer your question, your queries. How much programming is needed? How much data analysis is needed? What kind of challenges are cool? Space exploration, or save the Earth, save the climate, or new space, right? In the United States, they are talking about new space, and that's something very cool. Okay. So without further ado, let me hand over to Mr. Tong.
Hi everyone. So my name
name is Tong from the Hong Kong Australia. So I used to be a weather forecaster, but then I'm now working in the division mainly responsible for climate forecasting and climate projections. So today I'm going to talk about climate change. And climate change, I think, which is now the biggest challenge of our time, apart from COVID-19, of course. So I would say that climate change is one of the biggest challenge in this generation. So I'm going to talk about climate change and see what kind of innovation or inspirations I can give to you in this climate change challenge. So the causes of climate change. So climate change actually is a long-term trend of changing weather. So, but there are many different kind of reasons for climate change. Climate change can be natural and also can be human-induced. So natural, there are many natural reasons for climate change. Say change of ocean conditions, change of land, and changes of volcanic activities. Because if you emit all those aerosols into the atmosphere, then it will cool the Earth down. So also it is the Earth's orbital shift is also very important, because if you change the orbit of the Earth, obviously it will affect the energy you receive on the Earth. So there are natural causes for climate change. But there are also human-induced causes for climate change. Say the changes of greenhouse gas concentrations, the change of aerosols, because since the Industrial Revolution, we emit a lot of greenhouse gases, also aerosols into the atmosphere. This kind of greenhouse gas and aerosols will also have a significant impact on Earth's climate. So changes of land use and also urbanization is also a very important cause of climate change. So you cut down all the forests, all the trees, all the woods, and then the concentrations of carbon dioxide will change in the atmosphere, and that will of course have an impact on climate change. So. As I said before, there are natural reasons and also the human-induced causes of climate change. This graph actually shows the carbon dioxide concentration in the past 800,000 years. So you should already know that CO2 is the most important greenhouse gas in the atmosphere. So you can see that the concentrations of the CO2 actually change in the last 800,000 years. But you can also see that in the most recent, say, 200 years, there is an abrupt increase in the concentrations of carbon dioxide. So the latest figures in August 2020 is around 400. It is already about 400 ppm. ppm is just a unit of the concentrations of CO2. So natural causes is most unlikely to explain the abrupt change of CO2 concentration, especially during the past 200 years or so. So you can see that you can say that this is a natural variation of CO2, but natural variation of CO2 can explain the very abrupt change of CO2 in the past 200 years. So if we look at the temperature in the past 10,000 years or so, actually the past trend of temperatures of the Earth is showing a cooling trend in the past 10,000 years or so, before the Industrial Revolution in the past 200 years. So you can see that the temperature abruptly increased in the last 200 years. So this is the effect of Industrial Revolution and the human-induced climate change. So here are the temperature records in the past 150 years or so. So we have a different kind of color lines here. So different kind of color lines with different set of temperature data. So scientists are always very conservative in the sense that they list a lot of independent data sets to verify the claims. So here we actually looked at different kind of temperature data set. So for example, this one is a data set produced by Met Office in UK, and then this one is by US, and this one is by European, and then KRA55 is actually a Japanese temperature data set. So they are all independent. So but they are telling the same story. What is the same story is that the temperature is rising in the past 150 years or so. So different kind of data set is just telling the same story. So actually this one is, sorry, I can't even. This one should be bonus 5 years on record. So the last 5 years actually is the bonus 5 years on record. So this is also an evidence that the climate is changing and we have no global warming. So as a result of global warming, we can see that the glacier is losing its mass. So this basically is the global annual mass change of some reference glaciers. And this one, this graph on the right-hand side is actually the mass change of another diagram showing the mass change of reference glaciers. So you can see that basically the glaciers are melting and they are losing mass. So also Arctic sea ice extent, we are looking at of those Arctic sea ice floating on the ocean, and they are also on a very significant increasing trend. So these two graphs is actually looking at the ice sheets over the Antarctica and Greenland. So they are both on a very significant decreasing trend. So all of the reference glaciers, Arctic sea ice, and ice sheets all showing the same story, that they are losing mass. They are melting because of the global warming. So as a result of the melting water from the ice sheets and also the further expansion of the ocean itself, we've got a problem called sea level rise. So this is actually the sea level in the past 100 years or so. So different lines again showing different data sets. So they are also telling the same story, that the sea level is rising. And so in the past, say 100 years ago, we've only got tidal records. So they are not very accurate. So in the recent years, we have got satellite record. Satellite record also showing the same story, which is that the sea level is continuing to rise in the past 20 or 30 years. So it is a very interesting question whether the COVID-19 we have experiencing now have any impact on the carbon emissions or the global warming. Will the COVID-19, due to the reduction of economic activities, will it able to stop or will it able to slow down global warming? So WMO is the World Meteorological Organization, which is the highest authorities for the meteorological societies or the communities. So they have already said that the past experience suggests that the emission declines during the economic crisis are followed by a rapid upsurge. We need to change that trajectory. So they basically does not believe that the COVID-19 can slow down or even stop the global warming. So this is what happened what we expect to happen in 2020. That is correct. COVID-19 could slightly slow down the emissions of CO2. So here is the graph of CO2, and the red line here is actually the previous forecast of CO2 concentrations for 2020. And the blue line here is what we expect to happen under the COVID-19 emission scenario. So you can see that yes, it is slightly slow down the emissions when you compare the blue line to the red line. But it can only just slightly slow down the increasing trend. So when you compare the CO2 concentrations with the CO2 concentration in 2019, where we haven't got the COVID-19 yet, it is still increasing. The CO2 concentration and the CO2 concentration is still increasing. So that means we can only just slightly slow down the emission, but it is not enough to slow the global warming. So we expect the temperature will go to still on the rising trend for the next few years. So I'm now going to talk about the climate change in Hong Kong because we are all living in Hong Kong. So Hong Kong is quite a special place. So we experience two events. One is global warming, and one is local urbanization. Because you all know that we developed to a very densely populated area in the past 100 years. So we basically what we see in our record that I will show you later is actually a combined effect of global warming and the local urbanization effect. So this is a general picture of what we have experienced in Hong Kong. Basically, all the features are consistent with the global trends. We obviously experience a rising trend in terms of annual temperature. We have also experienced more very hot days and fewer cold days, and we also experience more extreme rainfall, and we also see a rising sea, especially when we look at the observations over the Victorian Harbour. So this is a very simple statistics based on the observations at the Hong Kong Observatory. So we have the Hong Kong Observatory have more than 100 years of meteorological record. We basically start our meteorological measurements in 1885, so more than 100 years ago. So at the start of our measurements, the first 30 years of measurement, which is 1885 to 1914, we basically see quite a few any number of hot nights and very hot days. The number is quite limited, but we also experienced more than 25 days of cold days at the start of the measurement. So here is the definitions of what I define as very hot days and cold days. Very hot days is daily maximum temperature larger or equals to 33 degrees, and cold days is daily minimum temperature lower than 12 degrees. So for the latest 30 years, you can see that there is a very significant increasing trend for any number of hot nights and very hot days. And then actually we can see there is a decreasing trend for any number of cold days. So Hong Kong, such a small place on the map, also experiencing global warming. Of course, as I said before, this is a combined effect of global warming and urbanization. So this is what we observed over the Victorian Harbour. So unfortunately, we didn't measure the sea level for the Victoria Harbour 100 years ago. We just start to observe the mean sea level after 1954. So this is observations from 1954 to 2018. So we still observe a long-term trend for sea level. And you may ask a very difficult question, actually. Why there is seems to be a very abrupt rise of sea level in the 1990s? I have no idea, to be honest. I don't know. I don't know the reason, but actually we have seen similar rising trend around Hong Kong, say like Macau or some other stations for Hong Kong. So basically, we believe that this kind of long-term rising trend is reliable. But to be honest, I have no idea why the sea level here abruptly increased in the 90s. I have no idea. So climate change and also can cross over with extreme weather and cause very significant impact to our society. Not just I just showed you is just some meteorological records, but meteorological event or meteorological disaster can cause a lot of significant impacts to the society. So what is the relationship between climate change and extreme temperature events? So here is the distributions of temperature, which usually follow the Gaussian distributions. So when you got a new climate, the whole distributions of temperature will shift to the right-hand side. So you can see that if you got a new climate, so we expect there will be more hot weather, but there will be less cold weather here. And also, climate change could affect the variance. So here, for example, the width of the Gaussian distribution for the whole climate is here. But for the new climate, there will be the weather will be subject to more variability, so that the width of the Gaussian distribution will also change. So the combined effect of the shift of the Gaussian distribution and the change in variance will be like this one. So the new climate is that we will have more and more hot weather, but less change for cold weather. So we will expect that there will be more and more hot weather in the future following the new climate. So actually here is an example. This graph is looking at the extreme temperatures at the Hong Kong Observatory since 1884. So this one is actually counting the number of days with 35 or more, 30 or higher, 35 degrees or higher. So actually this figures say that during 1900 and 1909, there is only 2 days with temperature over or equals to 35 degrees. However, you can see that actually the number of days with a maximum temperature higher or equal to 35 degrees are increasing in the recent decades. So actually we observe 35-degree days every year since 2015. So there is a very significant increase in extreme temperatures in Hong Kong. Also, there are record-breaking number of hot nights in Hong Kong in 2019. So this is the long-term trend of hot nights. So you can see that there is a very significant rising trend. But the record was broken again this year. So even if the 2020 years have not yet finished, we have already observed that the number of hot lights has broken the record again. So this very long table is just showing the record-breaking events just for this year up to the end of September. So we have a very long list of new records. Most of them are related to high temperatures in Hong Kong. So I just picked up some interesting ones. So here we have a new record for the number of consecutive hot nights. So the new record now is 40 days. So also this one is very interesting. So the highest mean temperature for all months. This July in 2020 we have observed a highest mean temperature of 30.2. This is actually the first time we have observed a mean temperature over 30 degrees for a whole month in Hong Kong. So this one is a very interesting record. So we also have the highest mean temperature for summer this year. The highest mean temperature is actually quite close to 30 degrees already. So we have a very long list of record-breaking events just for this year. So this is not even a complete list. The complete list consists of more than 25 records. So I just pick up some interesting one for you. This is not a complete list already. So in terms of rainfall, especially when we talk about extreme rainfall in Hong Kong, this is a very interesting figures. So this one is actually showing the hourly rainfall records at the Hong Kong Observatory headquarters. So more than 100 years ago, we have hourly records of 88.4 degrees, 88.4 millimeters. So this record holds for around 40 years, and then this record was broken by another rainstorm in 1926. The new record then is 100.7 millimeters. And then this record holds for another 40 years until a new record in 1966 with an hourly rainfall of 108.2 millimeters. With a new record here. So afterwards, you can see that the hourly rainfall records is very easily broken in the past few decades. So the latest record is set up in 2008 with an hourly rainfall record of 145.5 millimeters. So you can see that we experience more and more extreme rainfall in Hong Kong. So you may not know, in the past we have some very severe rainstorm events in Hong Kong. So this table is just list out the more significant rainstorm events since like the 60s. So what is the significant impact of rainstorm? So 1972 rainstorm in June, it actually caused a very severe landslide. This one is the landslide over Soho Peak, if you know where it is in Hong Kong. So it actually killed more than 70 people in Hong Kong just for this event. So at the same time, over the Hong Kong Island, another very severe landslide over the Hong Kong Island. So the landslide actually destroyed a whole building in Hong Kong Island. This is what happened in 1972. So rainstorm, the meteorological record is very interesting, but bear in mind that a very severe rainstorm can cause a lot of significant impact to the society, and many people can be killed in such an event. So this is another example in 2008, which still holds the record of hour rainfall in the Hong Kong Observatory. So you can see that this rainfall caused a lot of landslide over the Lighthouse Island. And actually, if you won't remember, you are too young. But actually, the landslide on that day is very severe, such that the landslide actually blocks the highway connecting the Hong Kong International Airport and the city center. So this again caused a lot of very significant impact to the society. So this is just what happened in June. Another example of very severe flooding in Tong. And actually, it also happened just a few days ago, very severe flooding over the urban areas. So extreme rainfall can cause a lot of impact to the society. So climate change can also intensify future storms. Storms here I mean tropical cyclones. So actually, climate model projections continue to indicate that the increase in tropical cyclone risk in future because we have got a warmer atmosphere. We can hold more moisture in the atmosphere. It also got a warmer sea surface temperature, and if we got a warmer ocean, then most likely the tropical cyclones will be more severe. So also we have a big problem of storm surge. So and also this problem will be even more challenging because of future sea level rise. So this is actually what happened during the passage of tropical cyclones in the past few years. So if the sea level continues to rise, so you would expect this kind of situation will be worsened in the future. So that's what I mean, potential multi-hazard impacts to coastal areas, because we expect there will be more heavy rain, and there will be more severe storm surge, and also the tropical cyclone itself will be more severe, more severe, and also the sea level will continue to rise in the future. So most likely in the future we will face multi-hazard impacts due to extreme weather. So all of that disaster will come exactly at the same time: heavy rain, storm surge, wind wave, etc. So we are facing a really big challenge for those people working in the government, because they have to deal with the contingency plan. Also, they have to deal with the design code of the coastal infrastructure, etc. So this is just the tropical cyclone projections for the global or for different areas. So I just want to keep this one. I just want to talk more about storm surge. Maybe you don't know yet what is a storm surge. Storm surge mainly happen during the passage of the tropical cyclones. Tropical cyclones is a low pressure system. It's just like a vacuum cleaner. They suck up the sea level. So the sea level will rise at the center of the tropical cyclone. Also, the wind associated with the tropical cyclone will push the waters towards the coastal areas. So that's what happened in these figures. So the sea level will rise during the passage of a tropical cyclone. So this is what happened during the passage of two very severe tropical cyclones called Hackathon and Mangrove in 2017 and 2018. So this is the damage by the destructive winds and severe storm surge associated with these two tropical cyclones. So also, obviously this focus is taken in the business center in Central or in Kowloon, and you can see the broken windows. And you can imagine if we have got a lot of glass windows in Central. If we got a very severe typhoon in Hong Kong, the situation could be really bad. So also, given the fact that we expect the sea level will continue to rise, we will expect that high sea level events will become more frequent in the future. Actually, we have already seen this happening. So basically, we have done some statistical analysis. So in the past, I mean, just say 5 years ago, in the past, the return period of 3.5 meters would be around 50 years. What does it mean? It means that on average, high sea level events of 3.5 meters will happen every 50 years. So, however, after the passage plateau, the return periods of 3.5 meters have already shortened to 30 years. So after the passage of mangrove, the return period has already shortened to just 24 years. So we already seeing this kind of this kind of things happening. So high sea level events is becoming more and more frequent in recent decades. So this is just another example of a super typhoon called Hackathon. Hackathon in 2019. This is actually the track of this tropical cyclone. It actually hits the Japan and hits Tokyo here. So this is the satellite image of the tropical cyclone. And actually, this caused a lot of disasters or damage to Japan. So this is what happened to the trains in Japan. So the trains actually got flooded, and also they had to, as far as I know, they had to throw away all the trains because it is very severely flooded. So they can't operate the train anymore. So they just throw away. So this caused a lot of economical damage as well. So imagine what happened in Hong Kong with our NTR stations like that. So this is just another example that this kind of extreme event can cause a lot of damage to our society. So not just about precipitation, extreme heat can have a great impact to public health. So we actually have done some research in collaboration with CUHK, Chinese University of Hong Kong. We actually find that there's a high correlations between the heat index and also the long accidental hospitalizations. So as long as we have more and more extreme high temperature, we actually expect that there will be a great impact to public health, and more people, especially elderly, will need to go into the hospitals. So this is also related. The public health is also related to climate change through mosquitoes, because mosquitoes nowadays it's easier to transmit dengue fever because we have a warmer season, and they are actually expanding their territories. So the mosquitoes can now bite human beings in a warm winter or even autumn. So we expect the dengue fever season will be extended. So this is what we expect to happen in the future. So of course, high temperatures have implications on electricity consumption, because if you have a very high temperature, you will switch on the air conditioning, and we expect there will be more electricity consumption. But if everyone in Hong Kong switch on the air conditioning, can the power companies supply enough power to Hong Kong? That is the question. So the potential increase of temperature implies an increase in cooling energy consumption in Hong Kong in the future. This is quite obvious. So the question is, are we prepared for that? So our power companies prepare for that? So this is the challenge. Of course, climate change and coral reef, although Hong Kong also have much coral reef in Hong Kong, but actually climate change is closely related to the survival of coral reefs. If the temperature, especially the sea temperature, continues to rise, the expected coral reefs will all die and come to extinction. And of course, coral reefs in Hong Kong is not very common, but the coral reefs will the survival of the coral reefs will obviously have an impact on the ecosystem on the marine ecosystem, which will in turn will affect the fisheries. So the how many fish that we can get from the ocean depends on the marine ecosystem. So climate change has an impact on that. So this is another example of the impact of climate change and civil aviation. So this is an airport in Japan. So it actually flooded by storm surge caused by another super typhoon. So imagine our international airport in Hong Kong flooded like that. So can we? How long does it take to recover? So how long does it take to recover the whole international airport in Hong Kong, and how to deal with this kind of situation? So are we prepared for this kind of situation? Do we have any contingency plan? So that's all the challenge. So I may little sum up here. So climate change or extreme weather events. This is not just a meteorological record. This is not a meteorological record. This can trigger a chain of events. So such as just as flooding, I just mentioned, landslide, flash flood, storm surge, extreme temperature, etc. This kind of events could also trigger a lot of potential risk, like interruptions of transportation, water shortage, power outage, etc. So climate change could have a very significant impact to our society. So this is just yet another example of a storm surge, windstorm, and high winds. So this is the storm surge and overtopping waves and coastal damage over Hong Kong during the passage of two severe typhoons in the past in 2017 and 2018. And this is the windstorm. So imagine all the things, all the bad things, all the disaster happen at the same time. Could we survive? Are we prepared for that? So that's a huge question. And also the damage. How can the society could be recovered in a very short time? You all know that Hong Kong is a very international city. We have a lot of economic activities. Can we shut down for 2 days, 3 days, completely, and wait for the recovery of all those infrastructure? Obviously not. So we have to recover as soon as possible. So how can we do that? That's the challenge. So where are we heading to? So I hope that you all know what is Paris Agreement. Have you heard about Paris Agreement? So Paris Agreement is talking about trying to limit the global warming by 2 degrees compared to the industrial level. So this black line here is actually actual observations, and this red line here is the worst scenario. And worst scenarios mean the global temperature is expected to rise for about 4 degrees. And this two is actually medium low and medium high concentration scenario. And this one blue line here is actually the so-called 2-degree scenario. So what are we heading to now? So you can see that we are falling actually closer to the red line than the blue line. So first of all, we are still experiencing an increase of CO2 emissions in the past few years. We have not the CO2 emissions have not peaked yet, so we haven't experienced a decline in CO2 experiencing. So secondly, we are actually following the red line, which is the worst scenario. So we have to do something. So what are we heading to? So, well, you may thought that, well, we have got Paris Agreement already. We have solved the problem. No, the problem is not yet solved. Because based on the emission reduction practice amongst the governments, the global warming would be about 4.2 degrees by 2100. So that means we can't reach the 2-degree target yet. So that means we have to, based on some calculations obviously, so the reduction practice have to increase 5-fold in order to contain the temperature rise within 1.5 degrees. So all those emission reduction practice by the government all over the world is not enough. So we have to do more than this. So finally, what will happen for Hong Kong? So for Hong Kong, if we continue the 4 degrees trajectory, we are expected to experience more regular rainfall, more frequent weather, and rising sea level. Of course, 2 degree will be better, but we still expected to experience some changes in terms of climate. So finally, how to solve this problem, climate change. So this is the final slide of my talk. So basically, how to deal with climate change? We have we basically have 3 different areas to work to combat climate change. First of all, mitigations. Most importantly, how can we reduce the greenhouse gas emissions? Because this is the basic cause of climate change we experienced in the past 200 years. How can we reduce greenhouse gas emissions? How can we get everyone involved? Could we have some kind of innovation, some kind of apps, so that everyone can involve in reducing greenhouse gas emissions? And also, could we easily calculate the carbon footprint of any products we are going to purchase or buy? So mitigations also, obviously not during this event, but if you continue to develop and if you continue go for a career for any engineering or scientific area, you can think of new energy, green energy. Could we develop some kind of new energy that is carbon neutral, and also could we capture the carbon in the atmosphere and store it safely so that we can reduce the CO2 concentrations. Also, since we already experiencing climate change, so we have to think about adaptations. So we are expected to experience a warm climate in the future, right? So can we build a green building so that it can save energy, as well as the building itself is actually more comfortable to live in it. And also smart city, we have a lot of different kind of data, say temperature, say rainfall, say solar radiation, etc. We have a lot of information in the future. How can we make use of this kind of information and make a city smarter and better? So spongy city. So it is all about how can we develop a city that can adapt to more extreme rainfall in future. So we actually expect that there will be more extreme weather in future. So how can we make better observations? So we have all kinds of radars in Hong Kong, Turkey, and also in NASA. We have all kinds of satellites. We have a lot of different kind of observations. So how to make use of these observations, and also how to make use of these observations to improve our weather forecast. And we need to have a better prediction because we're expecting more extreme weather in the future. And also, how could we improve our warning system? Could we improve our rainstorm warning signals? Could we improve our typhoon signals? And the most important one, how could we communicate with general public? Usually, and there's some examples in US and also in Philippines. The forecast is correct. They can correctly predict the tracks of the tropical cyclones. The forecast itself is correct. The storm surge forecast is correct. But they don't know how to communicate with the general public. They can't convey the message to the general public. And that's what failed for some countries, say Philippines, because they can't receive the message from the authorities. That's the problem. So how can we improve our communications in future? So in the generation, you don't even watch the televisions, right? So nowadays many people already relies on their apps or relies on the mobile phones. So that's the end of my talk. I hope I can give you some inspiration on this biggest challenge of our time. Thank you very much.
Thank you, Mr. Tong. So we have, say, 5 minutes of Q&A. Mr. Tong, you want to stay here? So if anyone has any question for Mr. Tong on climate change, feel free to ask him. Go ahead. No.
Are you looking for more versatile cities that can deal with climate change, or are we looking to reduce our emissions more? Like, which one's more important right now?
Sorry, can you repeat your question, Zaka?
Are we looking for more versatile cities or less emissions? Which one's more important?
Versatile city or reduce the emissions? But both are important. We have to do it in parallel. So we have to reduce the emissions on one hand, and we have to prepare for the worst scenario. So we have to do both.
Yeah, go ahead. Yeah.
How exactly will a smart city look like?
But I'm not an expertise for this smart city. So you have to ask the drainage departments of the Hong Kong government. So they are actually, as far as I know, they are actually building something like a water park. So you have some lake-like features in a park, so that every time you have extreme rainfall or rainstorm, they can store the storm water in those areas. And then when the rainstorm passes away, then you can discharge the storm waters to somewhere else.
So that's basically is the idea of smart city. And also, it also depends on the material, say like the material on the ground as well. So if the material allow the water to pass through, then that's better.
Any more questions? Anyone? Yeah, go ahead.
What kinds of steps have the Hong Kong government been taking to address this issue, like any specific things that they've been doing? Like maybe improve our city and make us more prepared for.
Now, the Hong Kong government has already done a lot of things. Obviously, I can say that they haven't done anything, but they have done a lot of things. First of all, we have done our projections. This is very important. We have to know what will happen in the future, and then we will pass this kind of information to relevant departments, such as the drainage departments, such as the GEO department. GEO is responsible for the steep slope, and also for the engineer departments. Some may be responsible for the coastal infrastructure. So after we have passed those kind of projections, information to them, they will update their disciples. So, well, they will obviously tighten their growth so that our city can adapt to those changes in future. So another important thing is how it is the warning system. So Hong Kong Authority continues to improve our forecasting skill and try to improve our forecast system as well as warnings. And then we want to improve that so that we can deal with the extreme weather. And also another very important thing that is proper education. So as I said before, communication is very important. So even if our forecast is 100% correct, that's no use if people can't get the information from the Hong Kong Authority, can't get the information from the warning system.
Go ahead.
Also, I was wondering, like how you forecasting technically as well as like what's the current CFD
Sorry, I can't hear your last question.
what are the current CFD methods for like modeling or simulating these processes?
So for Hong Kong Authority, we actually based on a few weather models. So weather models is actually based on all the physical equations that we know, and then put it into a computer program, and they will compute the weather situations for the different days. That's how we actually forecast the weather. And for climate projection, this is quite different. We still use the model, but we use it differently. So we actually make assumptions of the greenhouse gas emission scenarios. Basically, we are not a crystal ball. We don't know the greenhouse gas emissions in the future, say 100 years. So we have to make some kind of assumptions, and based on that kind of assumption, we can project our future climate.
Any more questions? If not, we have ended this session by Mr. Tong. So let me thanks. Let us thank Mr. Tong again. So in fact, we have some souvenirs, which is because it's so coincidentally that today is also the celebration of the Mooncake Festival. Yeah, so we have a lantern. Later we still have a lot to give out. And as you know, the moon, right, is a natural satellite. And now, 2020, we have so many other satellites like GPS and so on. And they are used to, right? You use the moon to tell time and so on. So let's move on to the next part, which is we want to provide hackathon information. So So let me ask Alex to come back and give you, say, 10 minutes of rundown, describing what this hackathon is about. And later on, following that, we are going to hear from our VIP, who are also the judges, and they are all here today. Okay, and I will introduce them slowly one by one. They will also share with you what they look for as a judge. Okay, so Alex, you want to go through the hackathon information? Okay.
So now let me quickly talk about some general information about the hackathon. So it's a global hackathon led by NASA. So it's spearheaded by NASA, and it's hosted in hundreds of cities around the world. And on the official website, you can see a live map. So we organizers, we are called local leads. So we are the local leads in Hong Kong. It's quite slow. So here you can see the live map. So each stop is a city organizing this SpaceApps hackathon. And I think in the Greater China region, we have Hong Kong and Taipei, and that's it. So let me go back. So what we do is that every city we will nominate 2 teams, and we nominate these 2 teams to NASA, and NASA will do a final round of judging. And if you win from the global judging, if you are considered the best, you will be invited to NASA to watch a rocket launch. So this is a Wikipedia page, and it's just a SpaceApps Wikipedia page. And you can see that in the past few years, the winners, they were invited to NASA to watch a real rocket launch. But you know, COVID hits, and I don't know what we are going to do. So hopefully we will. And it's very important that your project must address one of the challenges listed on the website. So here are the categories, and inside each categories you can see the actual challenges. So these are the challenges in this particular category, and so there are like 20 challenges that you can choose from, and your team can work on just one challenge. So for example, let's say my team wants to work on this project, this challenge, and when you click on it, you'll see the details about the challenge, and you'll find some resources provided by NASA to get you started. And here you can see the teams, all the teams around the world working on this project. And pro tip, just a pro tip, you can click on them and see what they're doing, get some inspiration. I'm not saying that you should copy it. And of course, you all know that this year's hackathon is virtual. It's virtual all around the world. So let me remind you that each one of you must have an account on the official NASA system. So if you haven't, you must register an account to participate in this hackathon. Otherwise, we cannot nominate you. And each team must create a team page. So I've already sent you the team forming guide. It's a PDF. You can take a look. So on that team page, you can post regular updates. And here's an example. So this is a team page by a team in Taipei from 2018. And it's just a good example. So these are the updates posted by the team. It's just like Twitter or Facebook. So you post images and videos and whatever you want. You can post links. And it's just there to show us your progress. And it's very important that you do this because it will be part of the shortlisting process. So we will look at your progress, your regular updates to decide whether we should shortlist your team or not. So be sure to do that. So schedule. The hackathon itself starts tomorrow, And you will have 2 days, 48 hours to work on your project. And of course, you should, if you have any code, the code should be pushed to a public repository so we can see the code. And you should post regular updates, as I just mentioned. And late submissions are not allowed. And on the next date, we will announce the shortlisted teams. If you are shortlisted, you will be invited to a Zoom meeting. So for the final round of pitching. But of course, if you are not shortlisted, you are still welcome to join and learn from others. And we have 6 awards. And the 2 global nominees that we nominate to NASA will be chosen from these 6 teams. So if you want to be nominated, you should aim for one of these. Like for example, if you want to get the best use of data, you should use some kind of data. And like I would suggest that you take a look at the NASA OpenAI website. So this website is built by NASA, and they offer all kinds of APIs. So you can get all kinds of data for free, and it can be very useful. Let me go back here. Yeah, so you can decide like which award you should go for. And that's pretty much it. And I would like to thank our sponsors for their support. And before we invite our sponsors to come and share their insights, I'd like to
let's hear from one past year winner, Adit. So Adit, he is also part of the EDB Education Bureau program. So he joined this NASA SpaceApps last year, and he wants to share with us just for less than 5 minutes. He's going to share his experience so that you can join right this year and win something. You won something right last year. So Adit.
Hi everyone, I'm Arjun. I'm in grade 10 at Hong Kong International School. And I was hoping to tell you a little bit about myself, but obviously there's not enough time. So I'll just get straight to the point. So from this experience last year, I've been able to come up with 3 lessons that I want you all to, that I'd like to share with you all today. And hopefully you can, you'll learn something new and you can apply this not only to today's competition, but also into future hackathons as well. So the first thing is to be organized. So when I participated in the competition last year, I had 2 friends and I also had a college student working with me. And in this competition, we actually split up tasks. So I was a coder, one of my friends was taking pictures, another friend was working on presentation, and the college student was working on some of the research and the game theory. Now, I talked about game theory, and the reason why is because last year we actually made a game specifically for the younger generation. And the reason why we made a game was actually because we wanted to solve the problem of, some people are quite skeptical today of climate change, and some people, are not motivated to do things about climate change. And we feel that the best way to actually solve climate change problems, or even migrate to Mars or some other planet, is to actually motivate and encourage the younger generation. And the best way, we decided the best way was to teach them the basics of earth science through coding. Now, the second thing that I would like to teach you about is that you should come up with a backup plan. This is extremely important because, in the last competition, I was working till 1 a.m. with some of my friends on the project, and we were like half asleep, half awake because it's so late. And we thought that our project was building all right. We thought everything was fine. And so at 6 p.m. the following morning, we woke up and I decided to check the app and see if everything was working. I thought it was going to work, but in reality, it completely crashed and none of the project was working. And because of this, we had to have a mini discussion just shy of 2 hours before we had to present. And obviously, we were a little bit frustrated. And so the way we solved this issue was by realizing that, as it was mentioned earlier today, that, you have to show progress online and you have to upload your project to places like GitHub. And we actually did that. And because of that, we were able to download a previous build of our project. And because of that, we were able to, process properly. And so the main key takeaway is that if you are working on a project online, it's important to just save and document your progress. And if you're working on paper or by hand, then it's a good idea to come up with multiple solutions and come up with multiple drafts as well. The final, most important takeaway that I'd like to share with you all is to just have fun. So many people in this competition I saw last year, were a bit frustrated. Some of my friends were frustrated, And I think that it's a very good idea for you guys to just take this experience as just something to, you should basically learn about what you're interested in, and you should come up with creative solutions and experiment with new ideas. Don't worry, guys. This is not great, right? So come up with new ideas. And so, in conclusion, what I've told you today is that you should be organized. You should try and come up with new ideas and experiment with them. And finally, you should also have a backup plan. So I hope you were able to learn something today from this short speech, and thank you all for listening.
Any question for Adi? Any question for Adi? He's not going to join this year, so you don't have to worry. Join last year. Any question for him? Thank you, Adi. Thank you very much. So next, we are going to introduce the judge one by one, give opening remarks. But let me start with Tara. Tara, you may have heard from her a few times. She is the Princeton senior student who has created the Jupyter notebook, which you have been using right on and off. Let's hear from her, because she's also one of our judges doing this virtual judging. Very short.
Afternoon. Thank you for having me as one of your judges this weekend. As a fellow student in computer science and machine learning, I am very interested to see your approaches to the challenges this weekend and the new insights you uncover. Thank you for applying your knowledge and talents to coming up with these approaches to some of the world's most exciting opportunities, like space exploration, as well as considering solutions to some of the world's most immediate crises, especially those facing the environment. I believe many of you have interacted with the Python notebooks I created over the past few weeks. These were designed to introduce skills for understanding data and constructing predictive models. I think these skills will be useful to keep in mind when approaching many of the data sets available this weekend. They may also be particularly useful in a couple of the challenges, one involving quantifying carbon footprint, and the other about modeling human populations. As a judge, I'm very much looking forward to seeing all of your submissions. I am particularly interested in those which make understanding these complex challenges accessible to a broader audience, as well as those which clearly communicate how their contribution is useful to the given issue. I am also looking for creative approaches and well-evidenced solutions. Good luck this weekend.
Okay, so let me now introduce the judge who will come forward and give addressing remarks to all of you. Okay, so first let me welcome our department head, computer science department head, Professor Jia Xiaohua.
Okay, dear guests and dear students, first let me welcome you come to the CTU campus. And also thank you for your participation in this event. This NASA Space Application Challenge, it is a prestigious international competition. There is a reason why CTU is selected to host this event. That is because we have a group of highly capable young computer scientists like Dr. Shui Tan. Let me give you a little introduction about CTU's computer science department. CTU Computer Science Department is one of the strongest departments in Hong Kong. We have 6 IEEE fellows in our department. That is the highest honor in engineering. Most of my colleagues are graduated from the worldwide top universities like MIT, Princeton, UCLA, CMU, Cambridge. Dr. Tang is graduated from Princeton. We, by the US, there is a US News ranking. CS department was ranked the 11th worldwide. So that is the best CS department in Hong Kong. So let me take this opportunity to invite all of you to join us in this CS department when you come to university to study. Finally, my best wish to all of you to achieve good result and have fun. Thank you.
So let me welcome the next judge, Mr. Anthony from the U.S. Consulate General in Hong Kong and Macau, to say a few words and also to share with all of you. He was a judge last year as well. Some tips, Tony?
Sure. Good afternoon, everyone. It's really an honor and a pleasure to be here today. Dr. Tong, thank you to you and to the team for putting together another wonderful NASA SpaceApps activity. So, as Dr. Tong said, my name is Tony Takaro, and I am an economic officer at the U.S. Consulate. Some of you might be wondering, what does a U.S. diplomat have to do with NASA and outer space? Well, first of all, I represent the U.S. government abroad, including NASA, but also the ability to use and to explore outer space is at the heart of U.S. economic diplomacy. We accomplish this goal by seeking international support, by consulting with other nations, and by pursuing international agreements. One example of this is how the U.S. government participates in the United Nations on the Outer Space Treaty to make sure that outer space remains available for all people for its peaceful development, use, and exploration. Efforts like these are what keep satellites in the air. They monitor the weather here on Earth and in the sun and throughout the solar system. They help look for asteroids to make sure there are no threats to life here on Earth. They help run the apps that allow us to talk to each other, allow us to know where we are at in the world. They also help us look deep into space, back in time, until almost the very origins of the universe itself. And of course, we can't forget those amazing probes that are out there every day, including Curiosity on Mars, that's sending us these amazing photos and all this information, telling us about Earth's nearest neighbor. And of course, the Voyager spacecraft that are now out there beyond the very limits of the solar system. It's incredible. And every day they continue to search for some sign of life to answer that question of whether we are alone. And we're not done looking. There's still so much more to see and to learn, both out there in outer space and on our own planet. In just a few short years, we'll be going back to the moon. And this time we're going to the South Pole. And we're not going alone. We're bringing one of the first women ever to set foot on another planet. This is an incredible leap for equality. And we're not going to stop there. We're going to keep on going until we reach Mars eventually by the 2030s. But we're not doing this alone. This is a partnership with people from around the world. The Canadians, the Brits, the Europeans, the Japanese, we're all working together on a successful mission. These efforts are made possible through diplomacy, by communicating and talking with each other, by trying to find mutual understanding. Because curiosity and discovery, they don't belong to any one nation or one group of people. We all want to learn more about who we are, where we come from, and where we're going. And that curiosity starts with you. You're interested in the unknown, your teachers, your parents who are supporting you. These are essential for exploration, for solving the problems that we all face here on Earth and then beyond. So I'm excited to be here as you put collaboration, creativity, and critical thinking skills to work, using that as open data to try to solve some of these problems, to expand our understanding. So this weekend, what I'm looking for is for you guys to devise tools to observe and collect data in new ways, to think of ways to sustain life, to use data, old data that already exists in new ways, to imagine new technologies, to confront age-old problems such as natural disasters and economic and social inequality, and to connect and communicate with diverse audiences across the world. So again, finally, Dr. Tong, thank you to you and your team for putting this together. Thank you to all of you, the participants. And I wish you the best of luck, and as Adi said, have fun, okay?
We have something special for Tony, yeah, so the t-shirt and the letter and a small gift of token from CS department.
Yeah, you can guess what it is.
Is this a name card? Yeah. It's really nice.
Yeah. Thank you.
Thank you. So let me welcome the next judge to say a few words and give you some tips. We have two more. Maybe I go to Charles Mock. Mr. Charles Mock, everyone knows him. He's our IT legislator. Right? You see him on TV, now you see him in person. Isn't that nice, Charles?
Well, I want to keep it brief because everything that I want to say, Tony has said it, and Professor Tang and the Dean and so on. But I think I still remember the previous judging exercises I had before with previous contestants, and they were very impressive. And I think it's amazing that young people in Hong Kong, they have been able to come up with so many good ideas to help save the planet. I mean, when we think about NASA, we always think about going to the moon and going to outer space and so on. But in fact, it's also very important to understand that all these science exploration actually are, I think, intended to benefit people back on Earth. And we have a lot of these examples in the past and in future. In fact, I mean, we listened to the Mr. Tong's presentation about climate change. All these space exploration, all these scientific, trying to understand science from NASA's perspective, actually do bring us a lot of information and knowledge that help us understand about the Earth itself and how to save the people and the planet itself. I think is an understatement, and you've heard it so many times, that climate change is the biggest obstacles or the biggest challenge for mankind and your generation. So it is a good opportunity to use all the knowledge that you have and the tools that you have and the data that's provided to try to come up with some ideas and start with these ideas like you at a very young age. And I have to say that you guys are very fortunate because I do believe that you are the first generation that's going to be able to go to outer space yourself. I think it will be within your reach, definitely. Not sure for myself, but definitely for you. So it's a lot of exciting things that you can hope for and you can look for, and starting with the hackathon. So I hope you will have a great experience, and again, like everybody else saying, have some more fun. Thank you.
Thank you. Thank you. So last but not least, we have Mr. Gregory. Let me see. Give me a minute. Mr. Gregory, the last name. From Detroit. He's from Logitech, representing American Chamber of Commerce. So he's joining us for the first time. Let's hear from Greg.
thank you all, and happy Mid-Autumn Festival to all of you. So I guess you'll be working over the weekend, so it's always some fun. So my name is Greg from the area. I'm head of product at Logitech, and I'm also the co-chair of the Innovations and Technology Committee at the American Chamber of Commerce. Thank you for inviting me here. I'm super excited, and well done for the organization, guys. It's a super exciting event. I think first to react a bit to the presentation today, Logitech as a company has spent a lot of work in terms of being carbon neutral. We have announced that we're going to put a label on all our products in the future to announce the carbon impact. So we can all make an impact. And I think that's something that you really need to all think about, is that you all can make a difference, you can all make an impact, and in the next 48 hours you have a lot of chance to do that. So really think big. It was interesting, 2 days ago, since it was a Mid-Autumn Festival, my daughter of 3 years old was saying, tomorrow we're flying to the moon. So I guess in the next couple of hours, couple of days, you have a chance to do that. We, at the American Chamber of Commerce, we work a lot with startups community in Hong Kong, and we're very, very impressed by how innovative people are in Hong Kong community, and it all starts with you guys. And there's no age. I mean, if you look at all the amazing big companies like Microsoft, Apple, all that, started from guys that are 18, 19 years old. So really, innovation has no age. You can really have amazing ideas. You're a lot less biased than us. I mean, we all have our mind that is really limited by all the things we learn. And you have a lot of chance to really think big. So my biggest advice is to really think big. Think about the big problem you want to solve, and find some creative way to solve it. Don't be afraid of thinking big. It always takes you somewhere. Also with COVID, I think we have all learned how to study, how to work remotely. So yes, it's a challenge, but as I was introduced earlier today, is that organize yourself really well. You can do a lot more by being remote. You can be a lot more efficient, so really think about how to prepare yourself. And then finally, feel free to reach out during the refreshments. Feel free to ask questions, advice. We're here to help. And I'm really super excited to be part of this program and to listen to your presentations. Good luck. Thank you very much.
So thank you all of you. So now we are at the last stage of the session, networking session. Dinner is right outside.